We're going to start off Chapter 7 by combining 7.1 and 7.2 into a couple of days. It's going to cover graphing exponential growth and decay functions. So an exponential function, to start us off, is of the form y equals a times b to the x. The b value is the only value that has the exponent of x on it. It's called an exponential function because your variable x is the exponent. All right, in this you have what's called a growth factor. Your growth factor is your b value whenever b is greater than 1. And then you have a decay factor. That again is the b value, and it's called a decay factor whenever that b value is between 0 and 1. So exponential functions can either be exponential growth or exponential decay, and how you tell is by looking at the b value. Which one of these, growth factor or decay factor, would it be classified as? So the first thing we have to be able to do is look at an exponential model or an exponential equation and determine if it represents growth or decay, and then find the initial amount, the growth or decay factor, and the percent increase or decrease. So first thing we look at is our b value. If our b value is greater than 1, we are going to have an exponential growth model, and if it's less than 1, we are going to have a exponential decay model. So for A here, b value is this 1.3, and that's bigger than 1, so we know we have exponential growth for this. Now, with it being exponential growth, we have to find the initial amount, the growth factor, and the percent increase. The initial amount will always be your A value, so in this case it's 3.6, and then the growth factor is always the B value, which is 1.3. Now, percent increase, to find percent increase, you have to use this growth factor, and you either have to think about this as a percentage. So if I think of 1.3 as a percent, that's 130%. And I think to myself, how much larger than 100% is that? So that would be 30% larger. So 30% is my percent increase. For B over here, we again have the A value and the B value. This would be exponential decay because we have a B value that is less than 1, between 0 and 1. So now the initial amount here again is the A, so it's 2.4. The decay factor is your B value, so that's 0.78. Now again, think of this, if you change it to a percent, this would be 78%. So now you have to ask yourself, what percentage below 100% is that? So 78, if you take 100% and you subtract 78%, you have 22%. That would be your percent decrease. Now we'll graph 1, and then we'll look at a base graph for an exponential growth, and we'll talk about some key points that you have to remember. So if we're going to graph y equals 2 to the x, make a quick xy chart, t-chart here, and we're going to plug in the numbers -1, 0, 1, 2, and 3. So if I plug in -1, that's I have 2 to the negative first. I have to remember my exponent properties. That tells me that this would need to be flipped over. My y value would be 1/2. If I have 2 to the 0 power, anything to the 0 power is always 1. 2 to the first would just be 2. 2 squared is 4. And 2 cubed is 8. So these are points I'd be able to plot on my graph. So if I have -1, 1/2, do my best with the fraction. 0, +1, 1, 2, 2, 4, and 3, 8. So now this is a curve. All exponential graphs are curves. This curve would be that basic shape. Hopefully you do a better job connecting those points than I did. All right, so we know now the basic shape. We've seen it. Now let's talk about a base graph. How can we make these hopefully easy to graph for any of these exponential growth functions. So here again, your base graph is always going to be as the graph of the most simple form of an equation. So the most simple form of an exponential function is y equals b times x. Basically what we've done is we've let a be 1. And if this is going to be exponential growth, we have to remember that the b value's got to be larger than 1. So with any exponential growth graph, there's 2 key points that you need to remember. The first key point is that you'll always have the point 0 and 1. If you plug in 0 for x, no matter what the b value is, anything to the 0 power is going to give you 1. The second one is 1b. So if you plug in 1, anything to the first power is itself. So if we put just some example points on our graph, we're always going to have the point 0, 1. And let's say our b value, just to make this easy, is 3. 3 to the first would be 3. All right, so if we just let this example be y equals 3 to the x, those would be the 2 points we would have. And then we would connect those with our curve. We would know the general shape. It curves up. Holy cow, that's bad. Try this again. It curves up and away from the x-axis, and as it approaches the x-axis, it actually just gets really close. It never should intersect. It never should cross the x-axis. The domain of this graph, the x values that we could use, if you look at the arrows, the arrow that goes up is still going to the right a little bit as well, and the arrow on the left is pointing to the left. So the domain of an exponential growth is always all real numbers. The range is y is greater than 0. Notice I did not say greater than or equal to 0. All right, we've talked about this as well. You could have all real numbers greater than 0 for the range. You just have to remember you're talking about y values. The reason it can't be equal to 0 is because you have this thing called an asymptote. Okay, an asymptote is a line that a graph approaches and gets more and more close to it, but it will never touch, intersect, cross, however you want to say it. So the line that this particular graph gets really close to but never touches is this red line here. That red line is the line y equals 0. It's the x-axis. So if we use that to help us graph other graphs, actually, I'm sorry, this is not an exponential growth graph. This is an exponential decay. We can tell because we have our b value here. Remember, b is always the one that has the exponent on it. This b value is less than 1. It's somewhere between 0 and 1. Makes it exponential decay. So let's use these values for x. If we plug these in, we have 1/3 to the negative second power. This means we have to flip the fraction, which makes our exponent positive. So this is now 9. If we have 1/3 to the negative first, we flip the fraction, makes the exponent positive. So 3 to the first is just 3. 1/3 0 to the 0 is 1. Anything to the 0 power is always 1. And then we have 1/3 to the first. That is just 1/3. So if we graph those points, -2, +9, -1, +3, 0, 1, and 1 1/3. Now this also curves up and away from the x-axis, but it actually is curving down as you move left to right. So it's approaching the x-axis. So there's your general shape for an exponential decay graph. Looks a lot like an exponential growth graph, except now instead of as you move to the right, it curving away from the x-axis, now it's curving towards the x-axis. Numbers are getting smaller. So base graphs for exponential decay. Oh, come on. Oh. Want to cooperate. All right. Exponential decay. Remember, we know it's exponential decay when we have a b value somewhere between 0 and 1. Two key points for exponential decay. Nice part is the first one is the exact same as it is, in exponential growth. 0, 1 is the first point in both. Now, exponential decay, the second one's different. You have a negative 1, and then this 1 over b, this would be something to add to your notes, that isn't always going to be a fraction. That is actually just going to be the reciprocal of your b value. So again, let's say we just use a random example here. We'll go back to that one that we just had. Y equals 1/3 to the x. So if we use y equals 1/3 to the x, our 2 points that we would have would be 0, 1, and negative 1, and then the reciprocal of the b value. B value is 1/3. The reciprocal of that is 3. So we again have this graph that curves towards the x-axis. Domain of an exponential decay is again going to be all real numbers. We can use anything for x to plug in. The range is again y is greater than 0. It's everything above the x-axis, not touching the x-axis. And again, we have this asymptote that our graph is curving towards and will never touch. And that is always a horizontal line, so it's y equals, and that is 0. So in order to graph any exponential growth or decay function, you first have to decide whether it's growth or decay. You have to choose the base graph using either the points 0, 1, and 1b if it's growth, or 0, 1, and negative 1, and the reciprocal of b if it's decay. If you have an a value that's not 1, you have to do step 3 here, multiply the y coordinate of each by that a value. And then if you notice up here at the top of the screen, you have an h and a k value also. H is always up in the exponent, k is always not in the exponent. The h value always tells you to move either left or right, and this again, we've seen this before, you have to think opposite with the left or the right. The k value tells you whether to move up or down, and the k value also tells you where your asymptote is. So this is y equals k, whatever your k value is, that's where your asymptote will be. You could write the equation of it. All right, so let's say we graph this function. First thing we have to decide is whether this is growth or decay. To do that, we look at our b value. Our b value is positive 2, so this would be growth. Our b value is bigger than 1. So if we have a growth, we have to use the points 0, 1, and we use the point 1 and then your b value, which is 2. You do have an a value not equal to 1 at this time. Go back up here and label these. Your a value is 4. That means you're going to take each of your y values and multiply them by that 4. So you now have the 2.04 and 1.8. Those are the 2 points you want to start your graph with. 0.4, 1.8. Now, I wouldn't even draw the curve at this point because we still have to do a couple other things. We have to move our graph. Our h value looks like a negative 1. That tells us we're actually going to move this graph right 1. The k value is negative 3, which tells us we're going to move down 3. And our asymptote is going to be y equals negative 3 because of our k value. So if we have y equals negative 3, we draw a horizontal line through negative 3. There's your asymptote. Now take these 2 points, move them right 1 and down 3, right 1 and down 3, right 1 and down 3. Okay, now if this is exponential growth, we know it's going to curve up as we move to the right. So we can start at a point, it's going to curve up and away, and now as it approaches the asymptote, it's going to start leveling off. So now stating the domain and the range. Domain is all real numbers. Range is y is greater than -3. And your asymptote, well, I did these out of order, is y equals -3. All right, a couple more. Again, identify your different values. We know we have A, B, H, and K. B value is between 0 and 1 this time, so this is decay. So we know we are going to have the point 0, 1, and -1, and the reciprocal of the B value, reciprocal of 1/2 is 2. Our A value is 3, so we have to multiply the y coordinates by 3. So we now have the 2 points 0, 3, -1, 6 to start our graph. 0, 3, -1, +6. The asymptote we can say already because we know our k value. The asymptote, again, is horizontal, so it's got to be y equals, and it's 3, +3. All right, we also know that we're going to move left 1 because we have +1 for the h. We're going to move up 3 because we have +3 for the k. So each of these points move left 1, up 3, left 1, up 3. So this time we have 2 points that overlap. That's fine, that'll happen. We know our graph takes this basic shape for exponential decay. Finish this off. The domain is all real numbers. The range, y values that we're using, is everything that is greater than 3. It's everything above our asymptote. Now we have, oh, not cooperating. For 13, oh, there we go. For 13, again, not a bad idea to label your different values. B value is greater than 1, so this is going to be growth. If it's growth, we start out with the point 0, 1 and the point 1 in your B value. Now multiply all those y coordinates by your A value, which is -3. So we have these 2 points. So we know we have 0, -3. We have 1, -12. Based on the h and the k values, we're going to move right 1 and down 2. So right 1 and down 2. Here's my new point. Here, I'll do this in a different color. Keep them straight. Right 1, down 2. If I draw in the asymptote, we know the asymptote is always that k value. It's y equals -2. So we have an asymptote here. So now this looks different. If your a value is negative, just like we've had with other types of graphs, this is going to reflect our graph over a horizontal line. So now, again, your graph will always approach the asymptote, but it will not intersect the asymptote. So here we could curve through those 2 points and now curve towards our asymptote. Again, not touching it, not crossing it. Domain, still all real numbers. The range this time is y is less than -2, because now we are below that asymptote. The final graph Again, make sure you can identify, even if it means you don't have to write, that's fine. You still have to be able to tell me what the A, B, H, and K values are. Here, we don't have a K value shown to us, so this means it's 0. It's not shown. So looking at our B value that's between 0 and 1, we know this is going to be decay. Decay starts with the points 0 and 1. Negative 1, 4 in this case because it's the reciprocal of your B. Multiply those y coordinates by the A, so you get 0, 1, I'm sorry, 0, negative 3, and you get negative 1, negative 12. So we can put those on our graph initially. And now we know we're going to move right 1 because of our H value, and we're not going to move up or down at all because our K value is 0. So if I move both of my points to right 1, because my K value is 0, I also know my asymptote is y equals 0. So that is this x-axis. And again, your graph should always curve towards your asymptote. So there's going away, and as we get towards, it's got to start flattening off. So domain can use any x. So that's all real numbers. Your range is y is less than 0. So if you have any questions or you don't feel confident with any of this, feel free to go back, rewatch any part of the video you need to. Otherwise, the homework is the 7-1, 7-2, day 1 worksheet.